afternoon, and welcome back to Math with Captain Price here. So I'm making this video here to be an introductory video about the law of sines. So what we're looking at is a triangle, and I've already put some labels in it, and I'm using the labeling scheme kind of consistent with the current textbook here. Capital letters are for angles, and lower letters are for side lengths. And it's nice to put like side A, opposite angle A, side little b, opposite b, and C, and so forth. An important thing to realize, though, is that this triangle is not a right triangle. And that means all the stuff that we've learned about right triangle trigonometry, about sine theta, cosine theta, tan theta, do not directly apply to this triangle. Those only directly apply to triangles that have right angles. What we can do, though, however, is we can play a little trick on this triangle. And if we take this point right here and drop a vertical line, I'm going to do this in green. The length of that line, I guess I would call it a height, and maybe label it something like h. And now, if you look carefully, there actually is a pair of right triangles that we can mess around with. Here's one right here in red, one, where we have an angle A, and here's my 90-degree angle, and, well, that's supposed to be a straight line there, but. And then here's a second right triangle right here. And sine, cosine, and tangent, also Pythagorean theorem, do apply to those right triangles. So what we're going to do is we're going to kind of focus, kind of hyper-focus on this one, or tunnel vision, that's the word I want. Tunnel vision on this triangle right here. This is a right triangle because that's a 90-degree angle. The side H is opposite the angle A. So if we were to write out something for sine A, we could say that sine of, well, let's write this in a color that sticks out a little better. Sine of angle A would equal opposite, which is H, over the hypotenuse, which is C. All right, we're going to leave that alone for a moment, and now we're going to tunnel vision on this triangle over on the right. The sine of angle C is going to equal the side opposite C, which is H over A. Now, from the triangle on the left, we have that H is equal to C times the sine of A. From the triangle on the right, we have that H is equal to A times the sine of C. And that means these two things are equal. And this law is usually written, let's see, kind of grouping angles with its side together. Notice if I put the little a on the right and the big C on the left, what we have is sine of A over A is equal to sine of B, C over C. And there's nothing special about A, B, and C. I can take these angles and just move them anywhere I want. It's real easy to show that this is also equal to sine of B over side B. In this kind of double equal sign equation here is what's referred to as the law of sines. This applies to all triangles. That's very important. Normally we will apply it to non-right triangles, triangles that do not have a 90-degree angle in them. But generally speaking, it applies to all triangles. It can always be applied. Sine theta, cosine theta, and tan theta can only be applied to right triangles. They have to have a 90-degree angle in them. But law of sines, and what we're going to talk about tomorrow, law of cosines, both apply to all triangles. So this is just kind of meant to be an introductory video about law of sines. I'll save the examples for another video. Have a great day.